Great. Just a second. Our slide is coming up and we are good to go. Where are you? Again, while we wait, please feel free to drop in the chat your name, the country you're connecting from, as well as the subject or institution that you're affiliated with. You should see my screen in a second, and we will be right on our way. Technology has been very pleasant this afternoon. Yeah, got it. Apologies for the technical glitch. Come on. There you go. Hi, Dumbiru. It's a pleasure to see you again. Thanks for joining. Welcome. Adinde, Danilo, it's a pleasure to see you. Thanks for joining today's session. So just take us to the start. Interesting. Awesome. Good to go. Thank you for your patience. Good evening, good afternoon, good day, everyone. Welcome to this edition of the Africa Share and Discuss webinar series. My name is Shola, and it's always a pleasure to welcome you into our space every third Wednesday of the month, where we discuss ideas and strategies, of course, based from extensive research or extensive use in the classroom, methods or strategies that have proven effective, and how we can shift practices by bringing this insight down to everyone in the classroom to learn and also improve their classroom practice. And this edition promises to be insightful. My name is Shola once again, and it's a pleasure to welcome you. This is the Africa Share and Discuss webinar series brought to you by the PhET Interactive Simulation Project at the University of Colorado Boulder in partnership with the MasterCard Foundation. The PhET Interactive Simulation Project at the University of Colorado Boulder creates free interactive math and science simulations. These sims are based on extensive education research and engage students through intuitive or game-like environment, like you call it, where students learn through exploration and discovery. The project was founded in 2002 by Nobel laureate Carl Wyman. Our goal is to improve the global teaching of math and science, improve math and science education. And in line with this goal, this platform where we attempt to shift practice is one of the expression in which we support the effective use of simulations as an effective tool for teaching math and science across the grade level. So we meet every third Wednesday of the month, where we bring in seasoned researchers and practitioners to share their insights. And of course, these insights are research-backed, based on the experiences in their classroom. So this is the breakdown in terms of what the time might look like in your time zone, third Wednesdays of the month. And yeah, we're always excited to have you. Welcome to join us. So all this session is recorded, like you know. So for those who are unable to join us live, you have the opportunity to catch up on this recording. Please feel free to share widely with your friends and colleagues who might not be able to connect today. So I invite everyone to join, to visit the YouTube page where you find the playlist. Just go to YouTube and search for PhET Interactive Sims. You then find the Share and Discuss webinar series playlist, where you find all of the past sessions. If there are sessions or conversations you've joined in the past that you want to relive or pass on to someone, that's a good place And if you also know someone who's just getting started or is interested in research, that's a good place to pick it up or get started from. But before we introduce our speaker, just from housekeeping rules, while the session is on, we will not be taking questions. So we've saved enough time towards the end of the meeting to take all of the questions we might have, both for the speaker, but also if time would allow us, we'll be able to take some perhaps more general chemistry or PhET-related questions. But while the session is ongoing, we invite you to please use the question and answer feature here in Zoom to drop your questions. So drop your questions in the Q&A, just in the chat, perhaps, or preferably in the question and answer feature so that we can log and track and then ensure that we get to address all of the questions at the end. So don't wait till the end to drop. As the questions come to mind, I encourage you to drop them so that you do not lose that thought. And we can also ensure that we attend to all of the questions. And there's also a community on Facebook, as always. These conversations, an hour is just too short to cover a lot of the things that can be discussed on such a platform. So the Facebook community is a place where you can find also PhET users on the continent, where you can catch up with events and activities that are happening on the continent. So if you're not a member of that community yet, I invite you to consider joining so that, of course, you can connect with other users, but also stay abreast of announcements, events, and news as they break around PhET and its use in Africa. So that's the link. PhET Educator Africa is what you search for. And of course, once you request to join, you will be admitted into the group and you can connect with all our speakers. Today, I have the pleasure of welcoming Admit Zhoya. Admit is one of our super PhET fellows, but also, of course, is a chemistry teacher back in Zimbabwe, where from his experience prior to encountering PhET to now has been able to take advantage of PhET to help students get to conceptual understanding of rather abstract concepts in chemistry, most in particular, how students can visualize molecular shapes and their electric properties. So today is going to, of course, talk us through his experience, what worked and what does not work, and most importantly, some of the challenges he faced while navigating, of course, helping students move from a place of using the traditional methods to then taking advantage of tools such as PhET to bring students to a deep understanding of what is being taught. So today I have the pleasure of welcoming Admit. Admit, thank you for joining us. It's a pleasure to have you. I'll hand the mic over to you now.
Hello, everyone. Thank you, Sola, for the kind introduction and awarding me this opportunity. And I'm very excited to speak before everyone and give an account of how I managed to improve my students' understanding of molecular shapes and their properties, a case of Spindler High School, a level class.
Yep. Okay, you can share your screen now. I was just going to suggest that.
Spindler High School is located in Bindura Urban in Mashonaland Central Province. In Zimbabwe, our curriculum at secondary education goes up to 6 years. The secondary education is 4 years. At the end of the 4th year, students are awarded with an ordinary level certificate, which is an entry requirement to the A level, which is our advanced level, as well as polytechnic colleges. At the end of the 6th year, students are awarded with an advanced level certificate, which is a normal entry requirement for the university programs. In 2015, Zimbabwe Ministry of Primary and Secondary Education adopted a competence-based curriculum, which puts more emphasis on practical-oriented learning, as opposed to the prior curriculum, which mainly focus on content-based. On average, our A-level chemistry class contain 25 students, and mostly 12 boys and 13 girls. My students from previous years usually faced challenges in understanding molecular polarity. And molecular polarity usually depends on electronegativity as well as shapes of molecules, of which shapes of molecules depends on the student's understanding of how he or she construct the dots and the crosses as well as the displayed structural formulas of molecules. It was difficult mostly for the students to understand electronegativity, which is a property of atoms, since they cannot imagine what happens at atomic level. Because from preliminary courses, they learned that atoms, they equally share electrons during covalent bonding. But based on PhET simulation, which is molecular polarity, they are able to explain electronegativity. In the absence of models, the students face challenges in imagining the three-dimensional shapes of molecules based on the valence shell electron pair repulsion theory. Since they are used to two-dimensional graphs, as they are used to say the graphs consist of the x and the y axis. This is based on their mathematics background at ordinary level. So the concepts in chemistry, especially the physical chemistry, they are interconnected. And I also found that their understanding will stretch to previous topics, such as how to draw the atomic structure. So the atomic structure concept is also connected, also affects and used to explain the electronegativity of the atoms. So in the absence of models, the students, they fail to visualize the three-dimensional structure. Since in the case of Chipindu High School, they do not have sufficient models. I managed to have knowledge of PhET, which dates back to 2017, but I was not that effective in using PhET simulations. But I only just used just a few of the simulations, mostly the atomic, the building atom. During the 2020 COVID-19 induced lockdown, which negatively impacts our conventional learning process, our schools closed from April up to December 2020. So during that period, we were forced to shift to the online method, but the most popular method was using WhatsApp. But the WhatsApp was less interactive because we were just sharing the notes as well as some audio files. So in trying to make understanding much better, I revisited the PhET website and selected some simulations and teacher resources and aligned them to Zimbabwean curriculum. This, in using this PhET, I pre-record using the screenplay to record the lessons which I was going to share on the WhatsApp platform. And the students were understanding much better using that approach. So here is the feedback from my students based on PhET lessons. So students like Nashe appreciated the use of the Beers Knowledge simulation on how a colorimeter or a spectrophotometer works. Since our school is incapacitated to afford such instruments, so here are the feedback from my students, the few feedbacks. So it helps them understand the various topics, which include solubility, products, so the benefit of PhET simulations will also go to other subjects such as maths, physics, and biology. So the students generally appreciated the PhET-based lessons. Students usually develop important critical thinking and problem-solving skills, as well as a greater appreciation of scientific methods. And it promotes curiosity and creativity. Since the first sims, they do not have a prescribed method. And it allows deeper understanding of the subject matter. So here are some of the simulations. So students are upon drawing their dot and cross diagrams, they can use the build a molecule simulation as a self-assessment tool. So they can confirm whether the structures they draw are correct by looking at the 3 dimension and verify the number of bonds between the atoms. And since this sim has got a game mode, it can help them verify if they are doing their chemistry correct. So to make the understanding much better, by promoting active learning, I have used activity sheets and the whole class inquiry approach based on the availability, since most of the students, they possess their ICT devices, either a cell phone or a laptop. And because of the shortage of projectors in my school, they can use their cell phones. Then another simulation is the molecule shapes. So based on their ability to draw the dot and cross diagrams, students can they are able to visualize the 3-dimensional aspect and help them to assess their skill on the valence shell electron pair quotient theory. In this case, students are now able to visualize the 3-dimension We also have another simulation, the molecule polarity. I usually introduce the concept of electronegativity when addressing polar and nonpolar bonds, as well as intermediate bond types. So by using examples such as nitrogen, the atoms which have similar electronegativity, and compare their behavior in an electric field, and also the strength of bonds. For example, to explain why nitrogen to carbon bond is stronger than the nitrogen to nitrogen single bond. So in this case, one of the atom is more electronegative. So because of an additional dipole which is created between A and B, they can now visualize why A becomes more attracted to B, which results in a stronger bond. So next, Sola, can you play the video starting with the one with paraffin?
Sure. Just a second. Do you mind stopping, stop sharing your screen so I'm able to do that? Okay.
Okay.
On it. You should see my screen now.
Yes. Next video, using a charged rod with water.
Okay, you want me to play the second one right away, is it?
Yes, yes.
Okay. That's it. That's it. I just played that. Did you see it? Admit?
Yes. Hello?
Okay. Did you see the video? I just played the second one.
I can't see the video.
Okay, I'll stop sharing and then share my screen again. I wanted to be sure if okay, so I'll just play that again.
Yeah. Yes. Now we are using a charged rod. You can replay it again. So as the students were using a jet of water from the burette and the charged perspex, there was a deflection of a jet.
Do you want me to play it again?
No, I
Okay.
want to share my screen.
Sure.
Yes. Okay, then we proceeded with explaining why a stream of water was deflected when a charged perspex rod was brought close to the jet of water, but why paraffin failed, its jet failed to deflect. So, starting with a positively charged rod, the oxygen part, which is partial negative, is attracted towards the rod, but there's nothing which is happening if water is linear. In this case, water is linear. So based on molecular polarity, a linear water molecule is non-polar. Then also by using a negatively charged rod, the hydrogen atoms which are partially positive, they are now being attracted by the negatively charged perspex rod. But still, a linear water molecule has no effect on the charged rod. So this confirms the shape of water. So back to the molecular polarity simulation. So our B atom is now more electronegative than, so let's assume, okay, starting, this is water. So oxygen being at the center is more electronegative. So it is now having a behavior in an electric field because it now has the molecular dipole. But let's assume it's linear. The molecule no longer have a molecular dipole. So it means it is now non-polar. Based on the formal assessment from our National Examination Board, which is Zimbabwe School Examination Council, these are the pass rates for the previous 3 years for the chemistry subjects. So it was 89.7% in 2021, and it rose to 92.3% in 2022. And the current one is 100%. During the implementation process, I also faced a lot of hurdles. So mostly the problems which the problem A, the B, the second and the third, they are mostly connected with the first one, which is based on the administration, of which some of them are I cannot control, or the school has got a certain planning or budget. So our school has got limited devices. So the whole school, with about 1,300 students, has about 25 desktop computers for Form 1 up to 6 and one projector. We also have limited internet. So during the day, the internet is too congested. And internet is expensive. Say that most of the students, they rely on the social media package, which is like WhatsApp data only. And also our science laboratory does not have a secondary power source. So we face problems during power cuts, which affects our planning and also the implementation. So sometimes, as a teacher, I will have to use my personal laptop so that the students can gather around my personal laptop, since it can last longer without external power. So as a solution for the limited devices, I managed to install the PhET desktop app on students' personal laptops and share offline HTML files, as well as activity sheets via WhatsApp, as well as share it. And due to limited devices, I encourage students to share the devices. To counter massive power cuts, I acquired a small 12-volt battery and a solar panel. And I encourage students to bring cell phones because they are more economical in terms of power usage. As for the admin, they are, as a teacher, I usually expect instant results. But so if I request, for example, a projector, I usually expect instant solution, but they are currently working towards that provision of secondary power as well as additional gadgets. I encourage fellow educators to start even using just one laptop or a cell phone, because it helps the teacher to build confidence. Because these ICT gadgets, you cannot just bring them in the classroom and start demonstrating. And you also get real-time feedback to address challenges, and you also assess the effectiveness of certain interactive learning methods. For example, there is interactive lecture as well as work class and activity. So you can choose the method which works best for your students, also best with your resources. Because this technique or these pedagogies, they develop students' critical thinking and problem solving skills. And the students at the end will greatly appreciate scientific methods. And with this, I thank you.
Great. Thank you so much, Admit. Thank you for going every mile and touching it. Of course, it's obvious that you're a detailed and committed chemistry teacher, and with all the illustrations and all the details that you put in. I particularly enjoyed your presentation. In terms of all the detail, just like you mentioned, every bit was important, and for all of the experience, it's different when researchers make presentation, and it's different when classroom teachers makes presentation, because there's authentic feedback from the classroom which came through strongly, but also you're able to amplify some of the features built into PhET sims that helps overcome quite a lot, if not all of the challenges, things around the offline access, it's easy to share, of course, visualizing some micro-scientific concept and all of that. So if you have questions now before we go, please, this is a good time to start dropping your questions in the chat, and we'll present them to our speaker admits to just address all of them. So please, if you have questions, keep them coming, drop them in the chat, and we'll get to read them out for admits to respond in a bit. My colleagues are also looking at the chat, of course, the chat here, to pay attention to questions or reactions that you might have. Thanks again, Admit. You ended on a very strong note, which I think is a big takeaway from me. Start small and now. Start small and now. I'm sure that's particularly interesting to you. There might, or in most cases, based on our context, there'll be challenges in introducing tools or overcoming the constraints we have in our classroom, which you've explained. So I don't advise. I'm just re-emphasizing some of the things you said. But for how much support were you able to gather? Like how did the students respond? How did the school administrator respond to some of the things where and these are some of the common challenges I hear, or some of the constraints I hear. I don't get support. I'm waiting for the right context or for the right scenario to be able to take that jump. Yes, to start small and to start now. What mindset would you advise teachers to embody, or just to put, what did you have them put to heart once they are doing that?
Okay. Well, sometimes we might have challenges, especially in admin, to understand the current changes. There are current changes in teaching methods. Because when I went to the admin and said, when I need a laptop, they said, your department has got one, you can share that one. So they are not sure whether that projector is needed for everyday lessons. So I think by using this, like starting small, you can explain them at a later stage, so that they can show, like now I can present them that these simulations can do this and this and this, and they can make they can also lessen the budget. So mostly they admitting experiments they are only done using the physical apparatus and the chemicals. So if they bought the chemicals, they say everything is okay.
Awesome, great, thank you. Something that also stood out from the presentation is how you tactfully, more like, of course, they had some bit of apparatus to try, but to help students basically deepen their understanding, you're able to combine both the use of the physical experiment with the sim to help them see behind the veil, see things that they typically would not see in a lab. And I'm sure that fed into the reactions or the feedback you got from the students around, of course, being able to use it on the go, making it fun and engaging, and all of that. And I'm just, again, with that, re-emphasizing or reinforcing some of the
Yes,
benefits.
it was responsible.
Yeah, some
Yes,
of
it
the
was
benefits that
reinforcing.
PhET allows. But how do you then combine? Because it's exciting how your journey from COVID shutting down and everyone had going fully remote. It means you didn't have access to the physical laboratories, and then moving from that into introduction of the tools in the classroom to combining them. What advice do you have for teachers who have the opportunity to combine, or who are fully online, that they only can use the tool? Are there things to consider when they're in both contexts or in both scenarios from your experience? So for when you are fully remote with COVID, what does anything come to mind? What do you think teachers should pay attention to? And for when you're able to combine them, of course, students would like the more visual and simulations, but what are the things you tell teachers to pay attention to get the best out of using the simulations in both in-person and then remote scenarios?
Okay, I think the teachers need to understand the simulation first better than the students. So they must use the simulation. They have a better understanding of the simulation. And one simulation can be able to teach many concepts in chemistry. So you simply have to change it. So
Awesome.
in the presence of, let's say you've got both the physical lab and the virtual. So the simulations can, like the physical experiment can be used to just cement what they've learned at molecular level. So to improve their better understanding
Great.
of the concept.
Great, thank you. So we'll go to the questions in the chat now. So if you've not dropped yours, please feel free. But just before then, it's important to let you hear what the people are saying. Both Tabot, Dimberu, I see Eshetu, and everyone is saying, thank you for the presentation. Nice presentation, great presentation, thank you. I'm sure you brought new ideas or insights into how to, of course, supercharge or improve the experience in teaching molecular shape, both in chemistry and physics classrooms. Peter is also seeing good presentation from Kenya. I see Anonymous is asking, can I share the link to my colleague who wants to join when they see me joining? I guess that's joining the webinar. Yes, please feel free to join, to share the link. If you have that, it's shared by you. If you're on the call, I expect that you have access. But if not, if you drop their email or whatever in the chat now, we'll add them to the mailing list. And then but if you have the link, the same one you used in joining the meeting, please feel free to share. But also I'll drop the link to both the community on Facebook, as well as the link to the playlist on YouTube, so that they're able to catch up even if they miss now. That's another way to help them continue to learn and interact and join the conversation. Anonymous is also asking, what platform do you have to learn and relate aside from Facebook? Great question. So we have different communities and clusters. Facebook is one very open one that you can join. We have cohorts also learning and of course on the joining who are taking the course on Coursera or some guided experience. But the easiest place to get started out is I would advise is Facebook. And if you also, when you then find the opportunity to join a particular cohort for some coordinated or like for a cohort to learn, that's another place you can move from Facebook into perhaps a closed cohort that you can then use, maybe WhatsApp, which is often used to communicate and stay in touch. So the webinar is one place to continue to connect, and this happens once a month. Facebook is always there, so 24/7, every time a week, there's almost always someone online that can respond or help you get across to it. I should also add that we also have fellows in country. So we have like 30 plus fellows across the continent of Africa and in Latin America, in total about over 60, where you can also connect with, learn about us and learn their experience. Admit is sharing his experience from having come through that whole professional development experience and how that is transforming his classroom. So you can also visit the PhET website, see if you have a PhET fellow in your country, even if one is not in your country, if anyone is perhaps close to you, feel free to connect with any of them, and they'll be happy to answer and just guide you. So, and those are some of the lots of channels to get in touch, but those comes to mind at the moment. Tabot is asking, I wish to know if the data about the success rate based on PhET implementation is established by the Zimbabwean government or education board. If yes, does it mean that the education system has integrated PhET simulation into the national curriculum? That's for you, Admit.
Not yet. It is not yet integrated.
It's not great. So she's trying to understand, you're able to track the impact, of course, like you did mention that from the intervention of exposure to that, so their performance around chemistry, as in the molecular shapes, improved. So how were you able to track that? How, since the numbers were coming from the education ministry?
Okay, from the education board, we haven't presented the data or whether I'm using the PhET simulations, but I just approached the ministry on carrying out workshops to educate fellow teachers regarding the PhET sims.
Okay, great. Jean Paul is saying, I'd like to appreciate the presentation for this webinar. Thank you, Jean. Minale is asking, dear presenter, I appreciate your nice presentation. My question is that we know SIMS can help visualize concepts at sub-microscopic level, but what effort did you, what efforts you did to address other levels of chemical concepts, especially macro scientific and human activity in a real life context? So she's asking, yeah, students are able to visualize at the sub-microscopic level, but how did your teaching this topic help them develop other related skills, like of course hands-on, which I'm sure is reinforced both in the use. So I'll let you answer before I say what but do you understand the question? Should I go over it again?
Okay, go ahead.
Okay, so she's asking, we know that SIMs are effective in visualizing things that are not visible to the eye, but what effort, please, Minali, please feel free to write, or just if you would like to speak directly, we'll be happy to just allow you on mute and then speak directly. If I read the question wrong, what effort what did you do to address other levels of chemical concepts, especially at the macroscopic level, as well as the human activity? So there's the microscopic, there's the macroscopic, which is more as in bigger, as well as the human level. What other activities reinforced the learning at all of these levels?
Okay. Okay, so it's based on the molecule polarity. So the same principle will explain the solubilities of substances. So, and also polarity goes on to explain also the, okay, like other physical properties such as boiling points of substances. So I think based on this one, they can relate why certain substances got higher boiling point as well as they mix, they dissolve, they are miscible. But other simulations, they, like for example, like the ideal gas, they can be easily related to the physical world. Like, for example, to explain why tires best during a hot day. And also, we can also use like the another systems such as the greenhouse effect simulation. So that one can also, since we are always talking about the greenhouse and global warming, so we can explain also that to explain why the temperature in a car which with the closed windows, the temperature is higher than the outside. And in my country, they are using the concept of greenhouse gases by using a glass or a plastic to dry foods. So so some topics we can easily relate to the physical.
Okay, great.
Can
Yeah, please
can
go
I
ahead,
speak,
Minali.
please?
Yeah, sure. Please go
Okay.
ahead.
Okay. Thank you very much. I am male, not female.
Apologies.
My question is that we know that chemistry concepts have 4 levels of representations, just like macroscopic level, microscopic level, symbolic level, and context level. So at a chemistry education, or context levels of concepts should be linked to each other, be best understood by the students. Unless otherwise, it could be difficult for students to understand. So you made that an effort to present the submicroscopic levels. But I didn't see much you made an effort to address other levels of concepts, chemical concepts. Macroscopic. The microscopic means that just experimental activities, real experimental activities. You said real experimental activities are examples of macroscopic level of representation. And a symbolic level and context. You know that chemistry is has highly related with real life context. How much you made an effort to link chemistry concepts with contexts? It's my question. Thank you very much.
Thank you, Minali. I'm not sure if you saw the videos. Yeah, there were a couple of videos that were recorded, and because of our time, I'm trying to just go through this so that we love to respect everyone's time and not shoot it. Go beyond that. But I'll just play the video quickly again, where he was able to show the difference between charged objects and uncharged objects, and how that affects if there's deflection or of course the molecule attracts in the way. And so these are some of the ways, based on his examples and the illustrations he's made, that addresses that. I hope that answers your question. Okay. We can, and that's a good place to say, also remind us that if you're not on the group, yes, please feel free. We can take conversation forward to the group if that does not answer. We're just 2 minutes before the end, and I would love that we start winding down. I see a couple of questions around power rating, but unfortunately we can't get to that now. Please feel free to message. Admit is in the group as well on Facebook, so please feel free to, as in chat, write directly, just continue the conversation in there. And he also dropped his email towards the end of his presentation. Thank you, admins, and thank you everyone for joining this edition of the Share and Discuss webinar series. It's always a pleasure to have you join, and I hope that at the least you picked up one idea or method that you can take into your classroom tomorrow, or that would shift or help you better integrate vaccines and related technology to improve the teaching and learning of math and science on the continent. It was a pleasure to have you join us today, and we've come to the end of today's show. Please, of today's event. Please feel please join us again next month as we bring you amazing topics and speakers again to address some of the effective ways to teach maths and science on the African continent. Thanks, everyone, and bye for now.
Thanks.
Thanks, Admit. Bye. Bye, everyone.
Bye.